Hey guys, we're going to start talking about other types of regression models, and the main focus is linear, exponential, and quadratic. We did linear in the last lesson, but here on the box table provided, they give you examples of exponential and quadratic graphs, what they look like. So what they want us to do first for exercise 1 is they want us to, based on the scatter plot, determine which model would fit it the best. So you can do a couple of these on your own, but like this first one here, kind of looks like it's turning upwards, so this one's going to be exponential. In the case of what type would be growth, this one right here would be a quadratic. And then this third one looks like it's turning as it goes down, so that one would also be exponential, decay in that case. This one looks like it's pretty straight, so it looks like we're going to probably go with a linear. Okay, and then you can do the last two, fill those in yourself, as to which one you think would best fit each of those scatter plots. So we're going to move ahead to an example. So exercise 2 talks about biologists modeling the number of flu cases as it spreads. So I'm going to pull up the calculator, I'm going to pause the video, and I'll come back with the numbers in the stat section. So right now I have those numbers in that I was talking about, and it says for A, use the calculator to find a exponential regression equation, and they want us to round the parameters to the nearest hundredth. So they want us to use this form, A times b to the x power. So I'm going to go to stat, I'm going to go to calc, and exp, or exponential regression, is number 0. And I'm going to go ahead and hit calculate. I need a and b, and they have to be rounded to the nearest hundredth. So a is going to be 15.92. b is going to be 1.12. And then x is going to be our exponent. So having that now, we can answer the question. So B says, based on the equation, how many total cases of flu will there be after 2 weeks? So x is days, and they're asking about weeks, so we got to convert that. So 2 weeks would be 14 days. And we got to put 14 in for the variable it refers to, which is x. So I'm going to go ahead and I'm going to write my equation. But now, instead of the x, I'm going to put 14 in as the exponent. So I'm going to go back up to my calculator. I'm going to type that in. I got 15.92, parentheses 1.12, raise it to the x power. Oops, sorry, 14, because we put 14 in for x. So in this case, after 14 days, and since the answers in the table are whole numbers, we'd expect to see 78 flu cases. For C, kind of refers to what we talked about with exponential functions. What percent are the flu cases increasing? Well, that's going to be based on this value, which will be based on growth, which is 1 plus r, our growth rate. So in that case, it would be 1 plus 0.12, which is a percent, would be a 12% increase. And then the last part, you're going to declare an emergency when the cases gets above 200. On what day will they do that? Now, you can also input the equation into the calculator. And put in x, and then you can go to the table and search through the table. So we're looking to get above 200. So I'm going to scroll down. We know 14 was 78, so it's going to be above that. So based on this, the first day we get above 200 is 23 days, which I'm getting from this point, because that's when it jumps above 200. It gets to 215.75, or 216. So that's an example with exponential. Sometimes they'll tell you on the regions what type to use. Sometimes they'll have you decide. So you got to read the questions carefully for that reason. We're going to do one other one. We're going to look at exercise number 3 below. So I'm going to go ahead and kind of do the same thing I did for the last one. I'm going to go ahead and pause the video and then come back with these numbers into my calculator. So I'm back. I have my numbers in from the table. They're asking about why should a quadratic model be used. One way to determine which model should be used, if you go to calc, and this is when we talked about quadratic, if you go to calculate, you're going to see a value. In this case, they give you an r squared. The closer that r value is to 1, the more correct the model is. So in this case right here, a lot of times you'll see r, but this one has r squared on it. R and r squared are pretty similar and usually end up around the same amount. But in this case, if you're close to 1, if r is close to 1, that means it's a good fit. And for B, they want us to create a scatter plot. We're not going to do that right now, but we are going to go ahead and write the equation. So in this case, I'm going to go ahead and round this to the nearest, looks like I want to use nearest 1,000, but this one's going to be 0.001x squared minus 0.250x plus, move that over, this down, plus 16.863. So if I was to type this in, again, and get a table of values, you'd see a lot of these be pretty close to what the actual values are in the table. They might not be exact, but they're going to be close. So again, just to review, we talked about when to use linear, quadratic, and exponential. Also, make sure that you read the questions carefully to determine which type to use.